We're going to build an enable section in this video, and we're going to use this section along with the 1 byte of memory which we've already built in order to produce a register. So let's go to it. So that's us built our enable section, so let's go ahead and we'll see how this is going to work. What we want to be able to do is take the output from 1 byte of memory and pass it on to external circuit in the CPU. So for example, pass it on to the bus. And we want to gate the information out of that memory location onto the bus. And we do that with the enable section. Now we've got 8 AND gates here. One of the inputs is tied to the input here, and all the other inputs here are tied to the enable pin here, and all the outputs are tied to this splitter here, which is the output. So the way an AND gate works is it only allows a high output whenever both inputs are high. So it means that the information that's here on this side of the AND gate, it will only get passed over to the other side whenever the enable goes high. So let's see this working. So if I was to keep the enable low and I was to change all of the inputs to highs, you'll notice that none of these get passed to the output. They will only get passed to the output whenever the enable goes high. And when the enable goes low, it disconnects that. So that's how this is going to work, and we're going to use this along with the 1 byte of memory in order to produce a register. So what we want to be able to do is control the information that flows into the 1 byte of memory, and we do that with the set. And we want to control the information that flows out of the 1 byte of memory, and we do that with the enable. What we say is the set writes to the memory location and the enable reads from the memory location. So the set places information into the memory byte, and the enable passes that information from the byte onto the bus or some external part of the CPU. So let's go ahead now and we'll create the hierarchy for this. So click on Project, Add Circuit, and we're going to call this CPU underscore enable. We'll grab our circuit, Control X, and put it into the enable block, Control V. So now we can get in and we can change the circuit appearance. So right click, edit circuit appearance. So let's take the enable section along with 1 byte of memory and we'll produce a register. So if we get into main and we pick up our 1 byte of memory and an enable section, now all we have to do is connect the output of our memory location into the input of our enable section. There's an output from the enable and there's an input to the memory location. We've got a set pin and we've got an enable pin. So I'll go ahead and put these pins on and then we'll have a look at this circuit. We have here our register, so let's go and we'll see how this works. We have an input which goes into the memory location. We have an output which will go to some other part of the CPU. We want to be able to control the information flowing into the memory location, and we do that with the set. So the set will write information into the memory location. Now we want to control the flow of information out of this memory location onto the CPU, and that's done by the enable section. So we say that the enable will read information from the memory location and it passes it on to the CPU. So let's see this actually working. If we were to place information into the memory location, so that's us placing the information in, but nothing will actually go into the memory location until the set goes high. So whenever the set goes high, it passes this information into memory, and we can see that here the set's gone high and it's passed these ones into the memory, and if you go down into the memory there you can actually see it here, and that's set in memory. So now whenever the set goes low, that information is now held in that memory location. So if I was to change the input to the memory location, you'll see that when we get inside it, nothing will actually happen. We've changed the values at the input, but the memory has been set at all ones, and again you can see that it's all set at ones there. Now we want to be able to pass that information that's held in this memory location onto an external bus or some other part of the CPU. So we do that with the enable section. So we begin here at the moment. We have all the ones sitting here, but nothing will get passed on to the rest of the CPU until the enable goes high. So let's do that now. So if we set the enable high, you'll see all the outputs heading off to the external part of the CPU. So this will actually head off to a bus. So if we go back in there, you can see that this has passed information out. So that's how our register is going to work. So let's go ahead and we'll build a hierarchy for this. So we'll go into our project, add circuit, and we can call this CPU underscore reg underscore 8. And we get into main, we can cut, and we'll paste it into CPU reg underscore 8. We can then go ahead and we'll change the look of our appearance of the hierarchy. So I'll go ahead and do this now. So that's us finished building an 8-bit register. So we've come quite far. We've built a 1-bit of memory, we've built 1 byte of memory, we've built an enable section, and we've built an 8-bit register. So in the next video we're going to go and look at building a decoder. So thank you for listening. I'll get you in the next video. Goodbye.